What's up everyone, Jason Turley here. We're back with more TryHackMe challenges. We'll be looking at the Linux Server Forensics room. The description reads, learn about digital forensics, artifacts found on Linux servers by analyzing a compromised server. So scrolling down, you see that I've already started the machine. I have my IP address here, and there are 11 different tasks spread across 3 different VMs. So let's get started with the first task, deploy the first VM. I've already done that. It reads, you have been hired to investigate a data breach at Acme Web Design. Log in to the target machine using SSH with the following credentials. The username is Fred and the password is FredRules. Let's copy this IP address, go to a terminal. Let me zoom in a bit, make a working directory, then cd into it, SSH, help. Right, SSH, the username Fred at this IP address, answer yes to the prompt, and the password is Fred Rules. We're in, we see this welcome message, welcome to Ubuntu 18.4, some stats about the system, the IP address, the memory usage, and the last time anyone logged on was April 20th of 2021. Let's see, we're in home Fred, ls-l, there's a templates folder. Is there anything in there we need to be concerned with? Interesting. So these all look like web pages. We see about.html, we see contact.php, a robots.txt file. Let's go back here. All right, we did task 1. What's task 2 asking us for? The most significant attack surface on the server is probably the web service. Fortunately, the Apache access log keeps a history of all the requests sent to the first, the source address, the response code and the length, and then a user agent string. Every request from a modern browser should contain a user agent string that can be used to identify it roughly. The content of the user agent string is then used. We can also use the string to identify traffic for potentially malicious tools, as scanning tools like Nmap, SQL, Dirbuster, and Nikto to leak their identities, and then the rest is cut off for some reason. Alright, so it tells us to go to this directory, var log apache 2. So let's do that. We'll probably come back to this a little later. This home Fred directory, cd var log ls-l, and we see the apache 2 directory. Let's navigate to there. Clear the screen, ls-l. All right, we see 3 log files. One of them is empty, so we can probably ignore that. There's the access.log and then the error.log file. Let's go back here. Let's see what questions it wants us to answer. How many tools made requests to the server? And then name a path requested by Nmap. The hint reads try searching for the tool names, and the other hint reads Nmap will make requests to some strange paths. Okay, so let's open up that access.log. So anytime anyone tries to do anything with the website, it gets recorded in the access.log file. Let's open it up. Zoom out just a little. Okay, that looks a tiny bit better. Hopefully you guys can see that. We see a bunch of GET requests for different web pages. 200 means it was successful. So just scrolling through, we see that this is a lot of information to parse through. We see the user agent string. In this case, we see Mozilla, Firefox. So this was the web browser they used to access it. Up here we see Chrome, but down here we see Nmap. So Nmap was used to access the site as well. So that's one tool. And a little bit lower, we see Dirbuster, which is used to guess directory paths. So it was trying to get a directory, a subfolder called "There is no way that you can be there." And we see a status code of 404, meaning it's an error. We can keep scrolling. More hits for Dirtbuster. So the answer to this question would be 2. Nmap and Dirtbuster. Name a path requested by Nmap. Alright, so there's a lot of Nmap scans in this access.log folder. So I'm going to quit out of this, and I'm going to use a tool called grep to look for Nmap and access.log. Let's pipe that to less. Alright, there's still a good amount of requests. So let's filter this down some more and just grep for get requests. Okay, now there's only a handful of results back. If you go back to the question, we can look at the stars here and see how long the answer is. And the only one that matches it is this right here. Nmap lower check and then this number. So let's grab that and slam it in here. Move on to web server analysis. Web scanners are run against servers pretty much all the time, so this traffic is not out of the ordinary. Have a look around the site for potential attack vectors. Alright, before we go any further, let me grab this IP address and see if I can actually navigate to it. Yeah, and we get a landing page, Acme Web Design. We see some menu over here for home, products, about, and contact. Welcome to Acme Web Design Ltd, providing quality lorem ipsum since 1898. That's a long time. So lorem ipsum, it's just a placeholder text that a lot of websites use when they're testing out the design and the layout of the page. So it's a bunch of gibberish. It means absolutely nothing, but it's a way to get placeholder text. So we can poke around products. Okay. You can see the about page, and we'll see a contact page. And it actually has different fields for first, last, name, email, and some type of message. Oh, this is interesting. We can add an attachment. So maybe there's some type of upload we can do to get a reverse shell. I'm not sure. Let's continue on. But the menu here, the products and the about page, we saw that a little earlier. If I do CD to go back to my home directory, and then there's that templates folder. We saw these before. We saw about, we saw contact. So if I cat out, I don't know, index.html, this is the source code. This is the web page that we just saw. We see the welcome message. We see the lorem ipsum. We could, be cheesy and poke around and edit the HTML, change some stuff, and see if we actually change the content of this website. But I'll leave that as an exercise for you guys if you want to change any of the HTML. So what page allows users to upload files? All right, we saw that. That was the contact.php. What IP uploaded files to the server? There's a hint. Search the log for post requests. All right, before we go any further, I think it'd be useful to explain the different types of HTTP request methods. So HTTP, that's the service for web browsing. It runs on port 80 by default, and HTTPS, the secure version, runs on port 443. So when your computer interacts with web browsers and websites, they use, underneath the hood, different kinds of request methods. The most common is the GET request, which is just saying, hey, I want to access that web page. So we saw a bunch of those in the access.log folder. We saw some legit ones, and then we saw some malicious ones with the Nmap and the Dirtbuster scan. The next question asks us about uploading files. So GET is how you download something, and then the POST command, the POST request method, tells that web server that you want to upload some type of file. So if we go back here, let's go back to the cd log apache.log. Let's look at the access.log again. Grep post. So these are all the attempts of someone trying to upload a file to the website. So there's two results, one with code 200 and one with code 404. As we discussed earlier, code 200 means it was okay, it was successful, and 404 means there's an error. It asks us for the IP address, and we have that right here. This is the IP that tried to upload something. Paste that in and submit. Who left an exposed security notice on the server? Looking at the hint, Dirbuster already located most of the files in the server. Have a look at the access.log and see what it found. Alright, let me clear my screen. And now let me grep for Dirbuster in that access.log. Whoa. So this is still a lot of results. So let's keep chaining these greps together to narrow it down some more. Let's only look for GET requests. Okay. A little less. Still a lot. Scrolling through. Not really seeing anything yet. Let's filter more for just successful results. Status code of 200. All right, we see slash, we see about, index.html, slash products. Okay, those are the different products we saw. This is interesting. The resources directory. Let's see what's in there. Let's navigate back here and do slash resources. All right, we get 3 different years. There are all terrible years in human history. And then we get development. Click on that. 2021. Okay, let's just keep following this down. Docs. Security. MD is a markup file. It's kind of like a .txt file, but prettier, with syntax highlighting. Sure, just open it up in Mousepad. That's a different text editor. We have to really got to sort out the contact pages. There's no validation whatsoever. I can't believe, and believe is spelled wrong, we haven't been hacked yet, Fred. We have to really sort out the contact page. All right, again, they can't believe they can't been hacked, so much so that they said it twice. So Fred is the person. Fred is the user who left that security notice. Let's paste in his name, hit enter. Persistence mechanisms 1. So it looks like our attacker got in via a remote file inclusion vulnerability. If you saw my last video, the root me, this is very similar to what we did. We uploaded a PHP reverse shell that called back to our attacking machine, and it gave us remote access to the server. It seems like something very similar happened here. So Linux and Windows, they have different persistence mechanisms. If you're unsure, all a persistent mechanism means is it's a way for your malware, your attack vector, your technique, it's to live on even after the system restarts or gets turned off at the end of the day and it turns on the next day. So cron are the scheduled tasks in Linux. So you could have a scheduled task that says, hey, every morning at 8 a.m. run this malware or call back to this IP address and I'll get my connection back. It can start up as a service. There can be a bash RC file. So anytime a user logs in, their bash runtime config file will be executed and the malware can start up there. It can be a kernel module or it can persist via an SSH key, which is a different way to log in to a system. Then it gives us a hint. It says cron is one of the more common methods, so start there. What command and option did the attacker use to establish a backdoor? So let's go back to our system. Let's clear the screen. Let's look at the cron jobs. Let's see if this command can help us out. All right. Let's do cron tab tech L to list the current user's cron tab. Fred doesn't have any cron tabs. Does root have any? sudo tackl. Alright, so I ran sudo tackl to list what this user, Fred, can run as the super user. And it says I can run all commands. So let's do sudo contab list user root. Root doesn't have any cron tabs either. What's going on? Let's look in var spool. All right, there's cron, at jobs, at spool, and cron tabs. Can we cat that out? Permission denied. Sudo bang bang. Oh, it's a directory. Let me just do sudo su. Let me change to the root user. This will make things a little bit easier. cd all right, I'm in here. There's nothing here. It asks us to look for the cron job. It's weird that there's nothing here. Let's do a recursive listing. All right, there's nothing in any of these. Let's look at etc cron tab. All right, that file exists. We see that there's some data in there. Let's cat that out. Nice. etc cron tab is the system-wide cron tab, and it gives us a description. Unlike any other cron tab, you don't have to run the cron tab command to install the new version when you edit this file, yada yada yada. Okay. It tells us the shell that it will use, binsh, the path environment variable. But here's what we're interested about. These are the different commands that will be executed. Some of these are legit, but this last one is not. So it's calling the sh, it's calling it shell with tack-i. What does tack-i do? Let's look at tack help. Oh, it doesn't like that. Man sh. Scroll down. All right, tack-i, interactive. Force the shell to behave interactively. All right, so it's opening an interactive shell on this port in this IP address. So this is the back door. Let me look at netstat. Are we actually connected there? No, so there's no connection to this IP address, but this is the back door. So this is the persistence mechanism. It's calling out to this IP address on this port all the time. So if we go back to our prompt, the command is sh tack-i, an interactive shell. User accounts. It looks like the command from the previous task was set up to run under the root2 account. This account doesn't make any sense, and there should only be one root user. Wonder how it got there. There are a couple of locations where account info is stored on Linux. This includes the etc password and etc shadow files. I know these names are kind of confusing, so it's cool that it breaks it down and gives us a description. So the etc password file contains the names of the most of the accounts on the system. People should only have read permission, and they should not contain passwords. So people should not be able to edit this file, except the root user. And it contains your password hash, not the actual password. It used to, but now it just contains the password hash. Or should not contain the password hash, excuse me. The password hash should be in etc shadow. So it asks, what is the password of the second root account? We can look at the hint that this attacker has been pretty lazy. The hash may have been copied from a forum post. So let's go here. Let's clear my screen just because I like to do that. Let's cat out scpasswd. Okay, so we see Fred, right? Fred, let's break down these fields. The first field is their username, Fred. The X here means there's no password stored in this file. The passwords are in etc shadow, the password hashes. This is his user ID and group ID. His full name is just Fred. His home directory, so when he first logs into the system, he'll be placed in home Fred. And his shell is bin bash. All these accounts that say no logon are false. These are not interactive accounts. They cannot log into the system. A lot of them are just service statements. They run in the background. We see the root user at the very top, and then we see root 2, which is weird. This should not be a thing. And their password hash is stored right here. Just for fun, let me cat out Etsy Shadow. And we see Fred's hash as well. You see how this is very long, whereas the root 2 hash is short? So this is probably not a very secure or very strong password hash. All right, let's echo their hash into a file. I'm just calling it root2.hash. Can I feed that to John? Does John like that? All right, I fed John this word list, user share word list rocku.text, and the hash. So while John goes and cracks that, let me grab this. Oop. No, John wasn't able to find it. What if I just Google search this hash? Does this give us any results? All right, we see a few posts, one from GitHub, one from Security Stack Exchange. Let's open these up. All right, the poster asks, if I have a worldwide Etsy password file, how can I escalate my privileges to root? Scrolling down. Passwords are normally stored in Etsy Shadow. Okay, we know that. Down here, you can use this non-destructive method. All right. So they're creating a password. They're generating a hash to create a second root user with Mr. Cake password. Okay, so this is the hash of Mr. Cake. I'm not sure why these two entries are different, but it looks like Mr. Cake is the password. The hint did tell us to look in a forum post. Is there anything over here? Yeah, same thing, Mr. Cake. Is that our answer? Yeah. So open source intelligence using Google is what we needed to do. Trying to crack it with this word list did not work. All right, just for fun, I echoed Mr. Cake into a file called word list. So if I cat out word list, right, it just contains Mr. Cake. That's the only thing it contains. And I ran John, which is the password cracker, one more time with word list against the hash, and you see here it cracked it. So that means that rocku, that file I used before, let me just open it up real quick. So this is rocku. This is a gigantic word list of some of the most common passwords. So if you see any of your passwords in this file, then you're doing it wrong. You're not being very secure. So it has a bunch of stuff. We see Sakura, we see Patrick, we see 99999. And I can search through, but there's nothing for Mr. Cake. That's why the password cracker could not find anything. Password crackers are typically fed a word list, and it hashes everything in that word list one by one, and it compares it with the hash that you give it. So that's the end of that little detour. Let's go back to the challenge. All right, that's it for that VM. Now it asks us to deploy the second VM. So it looks like they got hacked again. Better have another look. The creds are the same. Start this machine. Looks like I have to stop this other one first. It's yelling at me. Terminate. Start this one, and I'll see you guys once this spins up. All right, we have a new IP address because this is a new virtual machine that we'll be going after. All right, you can see I've been logged out of the other connection closed. Let's SSH into the new IP address. Yes. Enter the password, and we're finally in. It looks like it's another Ubuntu machine. PWD, what directory am I in? Who am I? I'm Fred. I can run sudo. Let me just confirm sudo tech L one more time, see what privileges I have. All right, I can run all commands as sudo, so I can basically become the root user. Clear the screen, LSFL, see what we're looking at. All right, we have templates again. All right, so far this seems like the same box as before. Let's see what it wants us to do. Apache log analysis 2. The log file is a lot smaller this time around, so it looks like our attacker was a little more subtle. There also don't appear to be obvious user agents anymore. Fortunately, there are a few other ways of identifying traffic originating from scanners. The time between each request is a good metric for most tools. You can also identify individual tools from signatures left in the requests. For example, Nmap will send HTTP requests with a random, non-standard method when performing certain enumeration tasks. More aggressive tools can also be identified simply from their number of requests sent during a given attack. Directory brute forcing tools are a perfect example of this, and are likely to fall foul of banning systems like fail2ban. So fail2ban, that's a IP blocker. So scanners, they always try to find hidden directories and subfolders on a website. They always try to find weak or default passwords, like we looked at with rocku.txt. Those are very easily guessed passwords. Well, fail2ban is a program that will look at these IP addresses. Hey, this IP address, it just sent me 20 requests back to back to back trying to find some directories. I'm going to ban that IP address. So that's essentially what fail2ban does. I recommend it if you run any type of server on the internet. A poorly designed site may also freely grant valuable information without the need for aggressive tools. In this case, the site uses sequential IDs for all of the products. It easily scrapes every single product or finds the tool size of the product database by simply increasing the product ID until a 404 error occurs. Whew, that was a lot of text. Probably too much. Let's go to the questions. Name one of the non-standard HTTP requests. Look at the hint. grep searches can be inverted using the tag v. For non-matching lines, search for get or post requests. Cool. So let's go back here. It wants us to again look at var log lsfl. All right, Apache is there. Let's cd into that directory. lsfl. Again, 3 log files. The access.log is a lot smaller. There's the error.log, and then the other host is empty. Let's look at the beginning of the error.log file. We didn't do this on the last VM, but just so we have a sense of what's going on. So these are a bunch of errors. These are things that did not go well on the server. We see a lot of shutdown messages. Cool. So we can also look at just the first couple of lines of the access.log, just so we can see what the syntax is like. So there's a bunch of get requests. That's a standard module, or standard method, right? So if I don't want to see the get requests, I can do tag v. So print everything that's not a get request. Oh, I get binary file matches, right? So if I run the file command on this, it says it's ASCII text. I'm curious as to why we're getting this. But we can fix this. Let's look at man for grep, the manual. Now there is an option on how to handle binary files. All right, let's try this. Let's do tac A or double tac text. Process a binary file as if it were text. So let's hit the up arrow a few times and then add a tac A at the end. Do you like that? There we go. We actually get output that we can read. So we did grep tac v, so everything that's not a get request, and treat it as text. All right, we get this hex 16 and hex 03. That's very weird. Options gxwr and then post. So post is normal, options is normal, but these two, the hex number and then the gxwr, are not normal. There's only 4 stars here, so we know it's gxwr. I'm curious what hex 16 and this ox3 are. Maybe that'll come up later. At what time was the Nmap scan performed? If we go back, you can see it was at 1330. Oh, this is not an nmap scan. Let me clear this. grep tech a tech in case insensitive nmap access.log. Oh, nothing for nmap. That's right. It was just telling us about the obfuscated user agent strings, wasn't it? Yeah, there don't appear to be any obvious user agent strings. So before, it would just tell us that nmap or dirtbuster was scanning, but there are no user agent strings for those tools anymore. But we know nmap uses gxwr, which is odd, and it's asking the timestamp for this. So 13:30:15. Persistent mechanisms 2. The adversary has been a little smarter this time around. If any backdoor exists, it's likely to be more suitable. SSH keys are another excellent way of maintaining access, so it might be worth looking for additions to the authorized keys file. The question is, what username and hostname combination can be found in the authorized keys file? Alright, so I have an idea of where this file is located on the system, but let's say I didn't. Let's say I had no idea where the file was. I can use the find command. Find, starting from root, the name of something called authorized keys. You're probably going to run into some files that you can't access, so instead of printing the error message, direct them to dev null, which is like the trash can. Hit enter. So it's searching the whole file system recursively. It's looking for anything named authorized keys, and let's see what it spits out. Nothing. Let's try again. This time, let's add some wildcards at the beginning and the end. We get this. This looks like a manual page entry, though. I don't think this is actually what we want to look at, and it's zipped up. Do I have the locate command installed? I do. Can I simply locate authorized keys? Interesting. lstech.la. I have no .ssh. Let me switch to the root user. cd into root, lstech.la. The root user has a .sh file. Let's navigate to that. There, authorized keys. Can we cat that out? We can. And at the very, very end, we see the username and we see the host name. All right, just for demonstration purposes, let's rerun this find command, but let's run it as the root user. There we go. It works. So I needed to run this original command as sudo or just by switching to the root account. So it didn't work because the authorized key file is in the root directory, which Fred doesn't have access to by default. So what is this authorized keys file? So when I logged in via SSH originally to the VM, I had to provide the username and the password. Well, this key file mitigates that. You don't have to do a username and password. You can just use the key. Just like opening a door, you can use this key instead of a username and a password. Let's move on to task 9. We're almost done, guys. Thanks for pushing through with me. Of course, adding a public key to the root's authorized key requires root level privileges, so it may be best to look for more evidence of privilege escalation. In general, Linux stores a tiny amount of program execution history when compared to Windows, but there are still a few valuable sources. This includes the bash history file. This is a file that contains all the commands that were run in bash. This file is well known and it's easy to edit, and sometimes it's disabled by default. There's the auth.log file. It contains a history of everyone who has ran the sudo command, and then there's a history.log file. which contains a history of all tasks performed using APT, which is a package manager on Ubuntu. It's useful for tracking who is installing and removing packages. Systemd services also keep logs in the journald system. These logs are kept in binary format and have to be read using a utility. We can't just cat it out. We have to use something like journalctl. This binary format comes with some advantages. However, each journal is capable of validating itself, and it's harder to modify it. The question is, what is the first command present in a root's bash history? So going back here, let me clear my screen. Let me go back. I'm in the root folder, ls-la. We see the bash.history file. We can just cat that out. And they opened up etc password in a text editor called Nano. And then they exited out. So that's it for that, but let's look at some of this other stuff. Let's look at auth.log. That's in the var log directory, ls-l, auth.log. And we see it's pretty big. What's the current date? So today is December 9th, and that's when the file was updated. So the file was being updated, it was last updated 3 minutes ago, right? It said it tracks when we run sudo. So let's see what's in there. I'm just gonna do tail to look at the most recent, the last entries. And what do we see? We see a timestamp from about 4 or 5 minutes ago. The user Fred used the command su, switch user to root. And then there's a bunch of related stuff. So I switched to the root user and it said new session opened. It was successful. It gave me a new sudo terminal. So cool. So we could keep looking through this auth.log file. This contains all the evidence of people using sudo. Just for fun, let me grep sudo from auth.log. Oh, it's a binary file. That's annoying. Tech A to treat it as text. So we saw on April 20th, Fred ran this command, user bin apt-get update. They upgraded. They did something called quicksetup.sh. They changed etc password to 777. That means readable, writable, and executable by everyone. Let's see if that's still the case. And it is. So anyone can edit this file. That's not good. And then it created like an AWS install log file. Since we're already thinking about it, let's just cat out etc password. All right, there's no root 2 user. I think this is kind of hard to read. There's too many no logon. So let's do grep tech v no login, or false. I think I have to do tech e and etc wb. All right, I don't think it likes that syntax. And then put quotes around this. There we go. All right. So I said, look for everything that does not have no login or false. So these are the users, Fred and root. All right. The final VM. Let's kill the current machine and then start up the last one. All right, we're back. We have our third and final VM with a new IP address. Going back here, we see our session is closed. We are disconnected. Clear the screen. SSH into the new one. Once again, answer yes. Type in the password. And we are on the target. Oh, a lot of weird stuff is going on. We see the last log on. A note pops up. Nothing suspicious here. Someone automatically ran PS. Nothing strange here either. Info. Reticulating Splines? Spleens? What is going on? Node graph out of date rebuilding. I'm not doing this. So something funky is definitely going on here. Wow, this system is really broken, huh? No kidding. Wonder how I can fix it. W? Is someone else logged in? No, it's just me via SSH. Gonna borrow your shell for a second. So this machine is totally messed up. Someone's running all these commands. They're talking to me. It's pretty funky. It's hard to even use this system. Let me do a PS Tech EFH. Let's see what's running. What's going on here? We see this bin bash Etsy network something.sh. Let me open this up. Whoa, okay. So Ghost in the Machine. That's the name of this script, I'm assuming. Things are still popping up, even though I'm in Vim. There's 12 different messages that I guess it's cycling through. We see print errors. So it loops through here and it just prints a bunch of stuff. It waits for 10 seconds. So every 10 seconds, it's going to print one of these weird errors. Introduce yourself. All right, we saw some of this text earlier. Wow, this system is really broken, huh? It's just popping up right in front of me, right on the screen. So this is the script. This is what's causing all this weird stuff to pop up on the screen. Let me go back here. What does it want? Okay, deploy. We did that. Persistence. Malware can also maintain persistence using systemd. As scripts run under the systemd, it can run in the background and restart. Okay, whenever it crashes. It is also relatively easy to conceal malicious scripts as they can blend in with other services. Systemd services are defined in .service. It contains commands, the user, and an optional description. In this case, the malware is pretty obvious as it seems to be printing errors to the screen. There's no way it is dormant. Running systemctl will list all of the services loaded. And much like Windows, there's usually a lot of them. It might be worth adding the type equals service and state equals active to the command. So it'll reduce the number of running services. All right, so we already found the name of the script, right? If I clear the screen and do another ps ef, we see it here, bin bash, but we don't know how it got here. The challenge told us it's installed as a service, so I can list all the services with systemctl. Type equals service. State equals active. Hit enter, and I get all the active services. It's saying one of these is weird, one of these the malware has created or has hijacked it. We see the SSH service, so that's legit. We see one for remote system logging, okay. I don't see anything related to the malware. It's pretty hard with all this garbage popping up. All right, just to make my life a little bit easier, I'm gonna look at this one more time and I'm gonna kill it. Kill, type 9, and that. It won't let me. Can I do it as sudo? ps tech ef. So I tried killing it and it looked like it came back with a new PID. So anytime I kill it, it's just going to come back and keep popping up. You can also see the name of the services here. Some of them at least. Let's rerun that systemctl command and double check to see if anything stands out. Is there anything that this malware has hijacked? It's almost unreadable with all this text keep popping up in between. This is a mess. Okay, if we look here, we see this ipmanager.service. So all of these have actual descriptions, but this just says ipmanager.service. That's a little wonky. Let me grab this, quit out of here, clear the screen for a bit. Systemctl status. of the IP manager service. All right, it's active and it's running. We get bash with that PID. That's the same PID that we saw earlier. I don't know if pgrep is a thing, but let's do it here. No, pstech-ef and grep out that. So the malware with PID 1719 is being started by this service. Oh, we can see it right here. I don't have to do that grep. So let's stop this once and for all. All right, did that work? Did it stop? Let's look at the status. All right, it's dead. So no more text should be popping up. We see the log here. It's stopping. It stopped. It's over. So that was a doozy. So just a quick recap. We logged on to the system and we saw this file was running, this script, and every few seconds it was popping up garbage on our screen and it made the system pretty much unusable. I tried killing it and it did work, but then it just came right back, and that's because it's running as a service. And the service would just keep restarting it with the new process ID. So let's answer our final question. Figure out what's going on and find the flag. I believe the flag was just the first thing we saw in this script. Ghost in the machine. So let's grab that. Let's copy it here. And we did it. So that one was a doozy. We went through 3 different VMs. We looked at the access.logs for the Apache web server. We discovered persistence mechanisms, cron jobs, etc password. So there's a lot wrong with all 3 of those VMs. So I encourage everyone to try this room, to explore, try that SSH key, see if you can use it. We saw that remote IP address earlier that was calling out to some IP on port 1234. Maybe that's something we can access so we can continue our triage and our investigation. That's going to do it for today, guys. As always, remember to like, comment, subscribe. Let me know if you found a different way to solve this down below. Take it easy and see you guys in the next video.